Welcome everyone to MavonX Desk. I am Alan Hordoin, your host, and we're filming side quest episode number 2, which we named "How Do You Believe Math You Cannot See?" And today I want to talk about the Monty show. Now, this has been done 1,000 times, and I don't want to repeat what other people have done because I think people did a great job of explaining the probabilistic stuff of it, but that's actually not what I want to talk about, because when I researched this a little bit more, I found out a piece of history that I didn't really understand. Now, I'm going to butcher his name because I can't pronounce, but there was a mathematician called Paul Erdős. And the only way he believed the Monty game show thing was with a computer simulation. It wasn't with math. It wasn't by doing all these math probabilistics, choices. Oh, if you do this, what's your probability here or there? It wasn't any of that. It was really a computer simulation. And what occurred to me is we can actually replicate that fairly easily today. And we could actually arm you to replicate it, right? Because we can actually show you how to build this in Excel very easily with simple formulas where you can actually replicate this. So the plan for tonight, let's go into Excel and let's build a computer sim. And for those of you who don't know what a computer sim look like, you'll be very shocked. But let's just to start off, let's just do a simple overview of the Monty problem, game show problem, so everyone's aware. So the Monty game show problem involves a couple key characteristics. There is you, right? That's me as MavonX. There's Monty, the game show host. And I always picture Monty having like crazy hair. That's just always in my mind. Monty. And then there's 3 doors. Door 1, door 2, door 3, right? And in the Monty game show, Monty asks you, pick a door. Behind one door is a car, and behind the other 2 doors are goats, right? So you get a goat. Here's my stick figure goat, and eventually you get a car, right? Boom. So you, as the game show contestant, are going to go pick a door. Now, you don't know what's behind any of these, right? So you're going to go, oh, I'm going to pick something. And let's just say you pick door 1, right? I picked door 1. Monty then is going to show you a door. Now, he will always show you a goat. That is the rule. That is the most explicit way to think about this. He will always show you a goat. No matter what you pick, he will show you a goat. So he, in this example, will show you this door. And the crux of the problem is that should you stay or should you switch, right? So do you stay or do you switch? That is the whole crux of this whole problem. And the theoretical limit is that if you switch, you have a 2/3 probability of winning. Now, that is what I don't want to go into, is how people actually calculated that, because I actually think that that's not the most interesting thing about this, right? If we go to building a computer sim, like in Excel, then we can actually see how close we get to this theoretical limit. And for those of you, that's roughly a 66.7% probability, right? That's what that means. So now let's go to Excel. Right now, here I have my trusty Excel up. Okay, so I'm gonna go explain to you some of these formulas used, and anyone can go build this at home. You guys could take a snapshot, look at the formula, replace it. I'll actually explain to you what the formulas does, so you don't have to worry. So we got these columns here. Let's walk through the column. Column A is trial. This is the trial we're doing in. So in this Excel file, I have 1,000 trials. Car is what door the car is behind. Pick is what door you would pick. If we removed your pick, what are the remaining choices? So remove player from choices. So you have choices 1 to 3 if you pick 2. If you then remove the car, because this is the, and we'll get to the formulas later. This is the idea, is that the game show host will always show you a goat. So what's the door left over with goats? So 1. So then he's going to show you a goat. And then column G is what's your choice? So you have to remember, so if you pick 2 and he shows you a 3, shows you a 1, then 3 means I have door 3 as a choice to switch over. Then finally, we have H and I. Column H is essentially just a 0 or 1. So stay to win means that if I stayed, if I won, if column B and C are equal to each other. So if 3 is equal to 2, I would win, and that would be a 1. If I switched and column B and G were equal, that would be a 1. So that's how it works at a very top level, right? And then what we do is then we run this for 1,000 trials, and then here what we're basically doing is using the average functions, which takes all 1,000, averages them, and then gives you essentially a percent averages. And the reason it's nice if you do 0 or 1 is that for any things you didn't win, you get a 0. And so it averages out to very clearly like a clear percentage, right? Because there's no partials, right? So and then that's a sneak preview, but let's get from there. So now, number one thing you need, the first formula you guys needed to go to build this is rand between. Rand between is a formula in Excel that picks the numbers between two numbers. So rand between 1 and 3 will pick 1, 2, or 3 randomly. That's the way to read it. And what we need rand between in column B to tell us our card choice, right? Then we can use rand between again in column C to say this is our pick, right? Again, you don't know the car, so you can do it this way, but I pick 1 between 1 and 3, right? Now, this is a little more advanced formula, but it's not too crazy. So what we need to do now is we have to calculate, because the game show we have to simulate, actually that's a better word, simulate the knowledge the game show host has. And the game show host always knows what door is the goat and what door is the car. So these next columns are eventually simulating the knowledge the game show has. So if you have choices 1, 2, 3, I want to remove your choice because I'm never going to show you your choice, right? So that's the way to think about it. So by removing your choice, you know you're going to get door was 1 or 2. The second thing is that the game show host will remove the car from the choices, right? So in here, we randomly pick 2. So it's going to remove 2 from this, right? So this formula in here, it replaces from these choices with an empty, that's what that means, the car choice. You guys can copy this, formulate it over again. To be more specific, find looks into a string and finds the occurrence of a string and returns its position. So, and then replaces in a string in Excel a value starting at a position. So I'm replacing in Excel at the find position with a blank, 2 with a blank. That's really what it's doing. The reason there is a if error is that if find doesn't find the character in the string, it errors out. So if it errors out, it just means you just return the string by itself again. That's all we do. So then we know that the game show host will always pick a goat. So there are scenarios where the game show host has only one choice to leave you. That's what this represents. And there's other choices that it has 2. So what this formula does is it says rand between, it says give me a random number in choices between 1 and the length of the string. So the length of a string with its 1 character is 1. When it's 2 characters, 2. So here on B it would give you 1 or 2. Here it would just give you 1. And then mid says go in the middle of a string starting at the position that this gives me and give me 1 character because it's 1. And that's all we do. So it's a cool little trick to mimic the knowledge he has, right? So he's always going to show you a goat. Now, your choice to switch to is always your pick minus what the open, and it's always going to be a goat, remember that. And then you have a choice to switch over to 2. So if you picked 1, he shows you 3, which has the goat, and then you go to 2, right? So now we have to say, okay, if we had perfect knowledge of the system, this is what it's saying. If I stayed, I would have lost. If I switched, I would have won. And we want to repeat this 1,000 times. So in Excel, the beauty about Excel, again, is that you could do this, right? See this little arrow here? that, and you could just drag it over and it just copies the formulas down. So you can do that for 1,000, right? And what's nice about that is then you can actually run a computer simulation. So for those of you online who are wondering like, hey, what's a computer simulation? We just ran a very simple one. Okay, so now let's look at the output, and this is the output. So what we're doing in the output here is we're saying average. And what does average do? Average will sum all the values from H2 from this point to H1001. And there's an indexing thing, and then it divides by the total amount of sum. So it will divide by 1,000 because there's 1,000 trials. And then if you do that, you get a percentage. If you multiply it by 100, you get 34.7. And then we do the same thing with the state of win, and you go 65.1. So what we've seen here is we actually are able to simulate this problem. And what we see is that a experimental value, because this is what it is, it's a computer experiment or a computer simulation, got fairly close to the theoretical value of 66.7. Now, what I've also done, and you guys can see it through a post on my website, is I actually built, using Claude again, don't want to claim work for I didn't do myself, but my Claude agent did it, I created a form that you can go on my website and play, and I'm going to show you the local version, and then it'll run the same way on the website. Okay. All right, so now we have the website version. And if you see here on the website version, I am actually running 100,000 simulations, right? And as we can see here, my number's really, really close to the theoretical, which is 66.7. That's the theoretical, or 66.66666 all the way to infinity. Now let's go down to 1,000, right? Just real quickly, we're gonna run 1,000. As we see at 1,000, our percent error dropped. Another way to think about this experiment that's going on is as you add more data, you're actually approaching the limit of the theoretical, which would be 66.67. That's really what's going on. So and you can see this here, right? So I do 1,000, I add a 0, so that's 10,000. 66.7, that's dead on. We could click this a couple times and we could see it go a little all over the place. I go 100,000, see very little, there's less movement. I go 1,000,000. Let's just see if the browser breaks at 1,000,000. There's hardly any movement, right? And that's because we got more samples and it's just approaching that limit. So what's cool about this is that, let's just say you did not understand the Monty Hall game show problem, right? You can take the rules of the problem, model it, and like we showed you, we actually modeled it very simple in an Excel document. And then you can go, hey, do I get what these people are saying? And that's the beauty about what I think is like having a critical mind. And I want you also to think about it this way. Sometimes it's much easier to find a contradiction than a proof. Let that settle in. I know that sounds very abstract, but it is much easier to find a contradiction than a proof. Because if you find one contradiction, it invalidates the whole assumption. Especially in mathematics, especially in engineering, in relationships, I don't think that really helps, but that's a whole different can of worms. But in mathematics and engineering, if you find a contradiction to a problem, it's actually one of the most powerful things you can do. And sometimes it's much easier to find a contradiction than a proof. So by us doing a computer sim, we easily set ourselves up to find contradictions, saying that, hey, let's just model the behavior, see what happens. And I hope you guys enjoy this. Please subscribe. Again, this is episode 2 of SideQuest. Thank you.